let's see some of the specialized arithmetic operators. So the first one is modulus. So modulus or remainder is if you divide a number by another number, whatever the remainder is will become your answer, right? So if I divide number 12 by 10, right, it will take 10 times 1 to be 10, right? I cannot say 10 times 2 because it will become 20, which is greater than 12, right? Just to understand, if I use mod, okay, and the number which is 12 and the divisor which is 10, right, what will happen is it will multiply 10 with 1, 2 and so on till the time it is either equals to this number or less than this number, but never greater. And whatever the remainder remains, that will be your answer, which is 2 in this case. Now I take the same example and I do quotient, right? Quotient is a similar to mod, but instead of giving you the remainder, it will give you the quotient, which is what is the maximum amount of uh, times that I have to multiply denominator to get a number which is equals to or less than the numerator to get my answer, right? So 12 quotient 10 will give you 1 because as soon as I say 10 multiply by 2, I get a number which is greater than 12, right? So there you go. Okay, rounding. So what happens is in Excel, we may see something like, uh, let's say equals to 56 divided by 11. Okay, so you will look at this number with a lot of decimal points, right? So it does not look good when you have a lot of such numbers, right, in your sheet. So what we can do is we can round these numbers, okay, to a specific number of decimal points, let's say 2, okay, and then we simply enter and we get is only two numbers after the decimal point, which is exactly what we have defined. So it will take the number as the first parameter, and you can define any number of digits here which will come after the decimal point. So if I, instead of 2, if I say 1, it will give me 5.1. Okay, so round up and round down are basically derivatives of round formula, but they have very specific purpose. So round up will give you the next number or next integer which is above your original number, and round down basically gives you the nearest integer um, to the original input. However, we can do a little bit of manipulation in terms of the inputs, and we can change the scope from integers to decimals or from integers to tens and hundreds, right? So let's see an example. I have 21.123 and then let's say 7. Okay, if I want to round it up, okay, just like normal, from 21 to 22, I'll simply say 0. So it will take that integer itself, right? But if I want to manipulate the formula in order to consider only two digits after the decimal point and round that up instead of just integer, what I can do is I can say 2. So it will consider these two digits and then round it up. So 1 2 becomes 1 3 and so on. If I do a negative 1, what it will do is it will take the number and first of all remove all the decimal points, right? 21 the initial number that we are remained with. Now minus 1 takes or it removes the first digit left to the decimal point, and it basically converts that into 0, right? So we end up with 20, right? But minus 1 also suggests that instead of integer, we are going to take the number in tens. So TENS, tens, it basically means what is the nearest integer to the original input in tens. So 20 rounding up to 30, right? Round down on the other hand, let's say 1, 2, 3, same number, okay? So rounding it down, let's take simply 0, will give us 21. Rounding it down in positive integers, let's say 2. So 1 and 2, since 1 and 2, it is what it is, right? There is no change that will happen because we are simply considering the exact digits that we have, right? And then if I do, let's say if I do -1, I get 20. So nearest integer in tens, which is lower than 21, it's 20, right? And that's round up and round down for you. Now, absolute value basically converts any negative number to positive numbers, right? And it keeps 0 and positive numbers as is. So we'll look at all the example. So absolute of 0 will remain 0. Absolute of 10 remains 10 because it is already positive. Absolute of a -10 will become 10, right? In a lot of cases we require it because we don't want some of the KPIs or metrics to be negative. Okay, so it converts that into positive. We will look at those examples when we do exercises. So factorial is a special mathematical operation which takes the number and multiply it to all the numbers which is less than that number up until 1, right? So if I take 3, I'll go 1 down to 2, I'll go another down to 1 and multiply all these numbers, right? Which will become 6, right? So let's do it using the function factorial of 3, it will be 6. Now factorial of 4 would be 6, which is the factorial of 3 plus, multiply by 4, which is going to be 24, and so on. Square root. So SQRT of 9 is 3, right? I hope everyone knows what a square root is. It's finding the number which multiplied by itself gives you the original number. So 3 multiplied by 3 becomes 9, which is the original number. Now let's look at text arithmetic, which is another special kind of um, addition of text, right? So for strings or text or alphanumeric values, we have concatenation as an equivalent of what we do as addition in numbers, right? So 1 plus 1 equals to 2, right? A plus A becomes double A, and so on, right? So we have ampersand or and symbol to concatenate or join two strings together, right? For example, if I do A and another A, this will become your concatenated string, right? I can do anything here and it will give me the result accordingly. We have concat as the function which does the exact same thing. So I can have A and then I can have another A with hyphen and it gives me the exact same thing. Now with this, we know about the basic arithmetic operations, the comparison operations, specialized arithmetic operations with the functions that we have used, and textual concatenation, right? This gives you the foundations of all the formulas that we have, um, which we generally use in a lot of scenarios.